everybody, today we're going to be learning about alloys. Okay, and what you need to know by the end of this lesson is what an alloy is and how they can be useful. And you need to know about a couple of different types of alloys as well. Okay, so an alloy is a mixture. And it works on the principle that the properties of a metal can be changed by mixing other substances with it. That mixture is called an alloy. So if we were looking for a definition, an alloy is a mixture where at least one element in the mixture is a metal. So an example of an alloy would be steel. In the pure metal form, we might have iron, which is completely made up of iron atoms. It's an element. However, you can add carbon to your iron and you produce an alloy, a mixture, which is called steel. Now notice that it says that at least one element in the mixture has to be a metal. Okay, it could be more than one or it could just be one. So in the example of steel, we've got a metal mixed with a non-metal. Sometimes you will find that the alloy is a mixture of two different metals. It depends on the example that we are looking at. Okay, so how do we do this? To make an alloy, you have to melt the metal and then you dissolve the other things in it. So you melt the metal and then add the other substances to it, giving a solution. You then let it cool and let it harden, and that's as simple as that. You have made your alloy. And turning a metal into an alloy changes the properties of the metal. Okay. With the most common change being that the metal gets harder or less malleable, less bendable. Okay, so most of the time, almost always in fact, when you make an alloy by adding another substance to it, you're going to make your metal harder. So why does this happen? Well, in a pure metal, the ions are arranged in a regular lattice. Remember that word lattice has a specific meaning. It means a repeating arrangement. Okay, so we can see in the diagram below, in the pure metal, that the ions are arranged in columns and rows, and they're very neat and very ordered, almost as if they're people standing in lines. Okay. What this means is that when we apply pressure to those ions, it's very easy for them to slide over each other and move about. Okay. That's why pure metals are malleable, why they are bendable into lots of different shapes, because it's extremely easy for those layers of ions to move and to slide over each other, not just in one direction. On the diagram I've shown it going left to right, but we could also apply the pressure vertically. That would work as well. They would still slide over each other. We could also apply the pressure diagonally, and they would still slide over each other. Okay, so they can slide in all different directions, and it's because of that regular arrangement that it's very easy for them to do this. Whereas in an alloy, the ions are no longer arranged in a regular lattice. The presence of the extra ions or atoms that you've added to it are disrupting the structure of the material. So when we look at them now, they're no longer as neatly organized, which means they're not going to slide over each other as easily. These extra atoms are going to act as kind of blocks to stop that happening. This is why the alloy is stronger. It's less malleable than the original metal because the layers cannot slide over each other easily. It's not only the strength of the substance that will change. Adding another metal can also change the reactivity of the metal. So it could make it more resistant to corrosion, for example. A good example of this is stainless steel. where adding carbon and titanium to your iron means that it is no longer going to rust. So most knives and forks are made out of stainless steel. The reason they don't go rusty is because of those extra elements. And it can also change how conductive they are, both in terms of heat and in terms of electricity, by adding different metals. Okay, that's it on alloys for now. Please go to the Google Doc on the Google Classroom and start to answer the questions there.